So remember that actually on 13 we have L and M parallel, but this time we have line J and line K are also parallel. So one of the relationships that I see right here is that 15y minus 48 plus 8x minus 1 equals 180. This angle and this angle form a linear pair. They add to be a straight line there. But what we have in that particular situation is that we have an x and a y, so we can't solve that one yet. So I'm going to draw a line right here. And let's look at our relationship here between the 8x minus the 1 and the 11x minus 25. And when I look at it immediately, I do not see a relationship between those two angles yet. So I'm going to come up with a relationship. And what happens is that this 8x minus 1 is underneath and to the right of the transversal. So 8x minus 1 can also be this angle right here, which is underneath and to the left of the transversal. And I'm not sure if I said that right. The 8x minus 1 is to the left of the transversal, so those are both there. So now we've got the 8x minus 1 in this position and the 11x minus 25 in this position. Lines J and K are parallel, which makes 8x minus 1 and 11x minus 25 alternate interior angles. And what we know about alternate interior angles is that they are equal. They are congruent. Let me say that better. Solve this the way your Algebra 1 teacher taught you. I'm going to move my letter to the left. So we get negative 3x minus 1 equals negative 25. Add 1 to both sides. We get negative 3x equals negative 24. And divide by negative 3. So x equals negative 8. And now that we know that, we can take this value of negative 8, which is really positive 8, because negative 24 divided by negative 3 is positive 8. We can take this value of positive 8 and put this back into our equation over here for x. Again, use Desmos if you need to. 8 times 8 is 64. And if we take a minute here to combine our like terms, negative 48, 64, and 1, I'll just pull up my calculator. Negative 48 plus 64 minus 1 gives us 15. So this is 15y minus 15 equals 180. We can add 15 to both sides. We get 15y equals 165. And when we divide both sides by 15, I think it's 11. I'm going to type it into the calculator because I have it. But let's see. 165 divided by 15 does equal 11. If we look down here at problem number 14, what we see here is we still have line L is parallel to line M. And if I start with the x's here, this angle, the 4x plus 4, has an x in it, and the 7x minus the 44 has an x in it. And these are, this angle, 4x plus 4, is above the parallel line and to the right, and 7x minus 4 is below the parallel line and to the left. So those are alternate angles, and they are exterior angles as well. And what we can say about alternate exterior, and I need to think about this for a second. Is that they are congruent. I don't know, I keep saying that. Congruent. So again, solve this the way your Algebra 1 teacher taught you, but let's subtract. I'm going to move my letter to the left, so I'm going to subtract 7x from both sides. We get negative 3x plus 4 equals negative 44. Subtract 4 from both sides. We get negative 3x equals negative 48. And divide both sides by negative 3. And we get a value for x of 16. So now we know that, and we need to figure out what the value of y is. So as we take a look back at that, I had to pause the video for a minute. So a couple things that I noticed here is that 39 is vertical to this, which is 39. And once that we know that, then I can also look at this from the perspective of alternate interior angles. If this angle is 39, then this angle is also 39. And then the relationship that we see is that this angle plus this angle forms a linear pair. So 39 plus 8y minus 43 equals 180. If we combine like terms, then we're going to get negative 4 plus 8y equals 180. Adding 4 to both sides, we get 8y equals 184. And if we divide both sides by 8, let's see, 8 goes in there twice. I think it's 23. Let me see if I can grab my calculator here. 184 divided by 8 is 23.